Hi, so this is the first video for Math 1105 for exponential functions. So in this video we will talk about what exponential functions look like. That's the format of an exponential function, some of the properties, and then what their graphs look like. So first of all, when we talk about an exponential function, we're talking about a function that looks like that. So a is a real number, it's the base of our exponent, and the exponent here contains the variable. That's something we've never seen before. We've never seen a variable in the exponent, and that's what makes these types of functions different from other types of functions. Now there are some restrictions on a. A can't just be any number. A has to be positive, and it can't be 1. So the reason why a can't be 1 is because if we had just 1 to the x, we know that 1 to any power is 1. So our function would just have values of 1 all the time. Well, that's not an exponential function, that's a horizontal line. So it doesn't really count as an exponential function. So there are really two possibilities for a. A is either somewhere between 0 and 1, so a fraction less than 1, or a is greater than 1. So those things will come up later. So first let's talk about every exponential function of this form. So if we haven't shifted things up or down, left or right, we just have some positive non-1 number raised to the x. So first of all, the y-intercept of this graph is 0, 1. And if we think about it, that makes sense. If we put 0 in for x, and we've got some number raised to the 0 power, we know that's always 1. So the y-intercept is 0, 1. Now, if this thing starts to have transformations on it, like if we add and subtract some things up here, if we add or subtract some things out here, this y-intercept is going to change. But this at least gives us a starting point. All right, now, remember we said we had two possibilities for a. A has to be positive and it cannot equal 1. So one possibility is that a is between 0 and 1. So it's a fraction less than 1, like 1/2, 1/3, 2/3, 5/6, something like that. If that's true, then the graph is always decreasing. And I'll just give you an idea of the shape it'll have. We'll graph these in a second, but it's going to have this general shape. Decreasing. All right, so that's if a is some number between 0 and 1. A could also be bigger than 1, like 2 or 6 or 1.9. So a can be bigger than 1, but this is really an if. If a is greater than 1, the graph is increasing. And this is the section where we can really start talking about these things happening in life. And right now we are experiencing this firsthand. The curve that we're talking about, flatten the curve, that curve is exponential. We are growing at an exponential rate, which is really fast. Now the graph is increasing. Our a is greater than 1. And so it has the general shape. It's supposed to be a curve. It's supposed to swoop. Let's try it again. There we go. So that's what it looks like if our a is greater than 1. So if our a is 2 or 3 or 4. All right, so those are the first pieces of our characteristics of an exponential function's graph. All right, but we have some more. What is this? 4? The domain of an exponential function is always going to be negative infinity to positive infinity. Because remember, the domain represents the values of x for which we have an output, a y that goes with it. Well, an exponent can be any number we want. We're allowed to put any number in for x here if we want. So our domain is always minus infinity to positive infinity. All right, the range is going to depend on whether or not you have transformations here, whether or not this thing has been moved up, down, left, or right. So the range is going to be everything, remember it's our y value, so it's everything we could possibly get out of a statement like this. Remember a is a positive number, and this is an exponent. So there is no way we can raise a positive number, a non-zero number, to an exponent and get 0 or a negative number. So the range, unless we have a transformation, is always going to be 0 to positive infinity. All right. Super important, not necessarily for today, but for the next video or the next lesson. These functions are one-to-one. And we know from the last video that if an exponential function is one-to-one, what that means is that it has an inverse that is also a function. That will come up in the next lesson. And then finally, these graphs have a horizontal asymptote. All right, for a plain exponential function that doesn't have any sort of alterations, no transformations up, down, left, or right, the horizontal asymptote is the line y equals 0. We also know it as the x-axis. And what will happen as we get close to the x-axis, either going toward positive infinity or going toward negative infinity, is that the graph will approach it, but never ever touch it. Okay, so now let's look at what these functions look like when we graph them. And really, it'll tell us how quickly these things grow. So let's graph f of x equals 2 to the x. So our a here is 2, and we just have 2 to the x, so we don't have any transformations. So we're really just going to look at kind of what a basic exponential functions graph looks like. And we're going to do that kind of in the old school way, making a table. But there are some things we know about this graph before we even start. First of all, if you look at the list of the things we just wrote down, first of all, we know that this thing has a y-intercept of 0, 1, because it's just a to the x. So we already know 1 point on this graph, 0, 1. We also know that since this a is greater than 1, we expect a graph that is increasing. So if we end up with a graph that is decreasing, something went wrong. We know the domain is negative infinity to positive infinity, and that our range is 0 to infinity. Okay, and we also know we're going to have a horizontal asymptote here. It's the line y equals 0, or the x-axis. All right, so let's get to picking some x values. Now, like we said before, these kinds of functions grow really quickly. There's a reason why the word exponential, just in English, has a meaning. It means it grows very quickly. So what you want to do, what I usually do, is start my x values where the where the exponent ends up being -1, because it's a little bit easier to graph those. The numbers don't get too small, and you kind of prevent things from getting very, very big. Another thing you can do is figure out where your y-intercept ended up and start 1x before that. So our y-intercept is still here at 0, 1, so we're going to start our x's at -1. And then we're just going to pick a few after that. We're going to stick with our rule of 5, that if we don't know what the picture really looks like, choose 5 x values. Okay, so now all we're going to do is just evaluate this function at those values of x. So our first value of x is 2 to the -1. Well, what we need to remember is what negative exponents do. It's not really anything spectacular. All they do is take whatever you've got and they move it to the denominator, and the exponent becomes positive. So 2 to the -1 is 1 over 2 to the +1. And we end up with 1/2. Okay, if we plug in 0, that's going to be 2 to the 0, so 1. We've already got that one plotted. If we plug in a 1, that's 2 to the 1, so 2. If we plug in 2, that's 2 squared, 4. And if we put a 3 in, that's 2 cubed, which is 8. I just put a little note here. So the way we got all these y values is by putting these values in for the variable, and we use them as an exponent on 2. Just keep in mind here, these are exponents, not multiplications. So now let's plot these. So we have -1, 1/2. 0, 1, which we already had, 1, 2, 2, 4, and 3, I'm going to just be really lazy and say that's 8. Okay, but we can see this thing is doing exactly what we expected it to do. It is increasing. We are going to get very, very close to the x-axis, but never ever touch it. And it's going to continue to increase. And in fact, it's going to double. With every increase of the variable, the y value is going to double. So this thing is going to grow very, very quickly. Okay. So now let's look at what happens if we have a transformation. It's really not that big of a deal. You don't really have to recognize the transformation. It just makes the graphing part and the picking of your values a little bit easier. Okay, so let's look at what happens if we've got an x plus 1 as our exponent instead of just an x. So our base here is 3, so we know this graph should still be increasing. And we have a plus 1 here on the x. We know what that means from our transformation section. Since this is happening to the x before the function takes place, this is going to be a shift left or right. And specifically, everything will be shifted left 1. That'll just make it easier to figure out where your y-intercept ends up, and it'll make your table a little bit easier to draw, or a little bit easier to fill out. So there's x, y, or f of x, if you want to call it that. And there's our plane. Okay, now if we just had 3 to the x, our y-intercept would be here, 0, 1, but we don't have 3 to the x, we have 3 to the x plus 1. So that point that would be here gets shifted left 1. So we really have the point negative 1, 1. Okay, so that was our y-intercept. Everything gets shifted left 1, ends up right there. So now this is going to help us pick good x values here so we don't end up with something far too big or far too small. So we're going to go 1 left of where the y-intercept ended up, and then 3 to the right. So we're going to start here at negative 2. And we'll see what happens. All right, what's important to remember here is our order of operations. So we have to remember that whenever we substitute in a negative 2 for x, this sum should be happening first before we do the exponent. All right, so first we're going to add negative 1 and 2 to get negative 1, negative 2 and 1 to get negative 1, and we end up with 3 to the negative 1 power, which is just 1 over 3. Okay, then we have negative 1. If we were to put that in, we'd get 3 to the 0. Notice I'm adding first, then doing the exponent. So we end up with 3 to the 0, which is 1. We've already got that one plotted. If we put in a 0, that's going to be 3 to the 1. It's 3. Put in a 1, that's going to be 3 to the 2, which is 9. And already when our x is 2, we have 3 to the 3rd, which is 27. So already at the value of 2, we already have a y value of 27. We're not even going to plot that. Okay, but let's go ahead and plot these. We have negative 2, 1/3, negative 1, 1, 0, 3, 1, I'm just going to call this 9 way up here. And it looks like we expect it to look. All right, we've got this function that is increasing because our a is bigger than 1, and we're just going to get closer and closer to the x-axis, but never touch it. Okay, so there's our graph. Let's look at one more, and we'll look at a different type of transformation, just so that we have it clear in our minds what we're supposed to be doing first. All right, and so our next example is 2 to the x with a plus 1 not in the exponent, but outside after the exponential part takes place. So we know what this means. Since it's after the basic function here, this is going to move everything up 1. All right, so we can still make our table. And let's go to our plane. Now, if this were just 2 to the x, our y-intercept would be right here. But this is not 2 to the x. This is 2 to the x with a plus 1 afterward. So the point that would be here in regular 2 to the x has now been shifted up 1. So there's our new y-intercept. Again, what this does, you would get this from making the table anyway, but it helps you pick some x's that are not inconvenient to plot. It helps the numbers not get far too big. Okay, so we're going to start 1 less than where our y-intercept ends up, so -1. And then we'll pick some numbers, I guess 5 values total. All right, then we start plugging in. So we're going to substitute these values for x up here. Now let's talk about how this is different from the last example. The last example, the plus 1 was in the exponent. That counts as a grouping symbol, so we had to do the sum first. In this case, the plus 1 happens after an exponent. So the exponent is going to go first, then whatever we get there, we're going to add 1. So 2 to the -1 is just 1 over 2. And we end up with 1.5. I would normally encourage you to write that as 3 halves. 1/2 plus 2 halves is 3 halves. But for graphing purposes, 1.5 is a lot easier to work with. Okay, if we put in a 0, that'd be 2 to the 0, which is 1. 1 plus 1 is 2. We've already got that one plotted. Okay, let's do a 1. If we put in a 1, that'll be 2 to the 1. That's 2. Plus 1 is 3. Put in a 2. That'll be 2 to the 2nd, it's 4, plus 1 is 5. Put in a 3, and we have 2 to the 3rd, that's 8, plus 1 is 9. So we know that this thing should be increasing. And one other thing that we know is that we're not going to be approaching the horizontal or the x-axis here because everything's moved up 1. So our horizontal asymptote was the x-axis. Since everything's been moved up 1, it'll now be the line y equals 1. So just shift everything up 1. So now let's start plotting some points. So we have -1, 1.5, 0, 2 is already there, 1, 3, 2, 5, and goodness, 3, 9 is way up there. But we see it's got the shape we need. It is increasing, and we're going to this time approach the line y equals 1 just because we have this plus 1 there that shifted everything up. So in the next lesson, we'll start looking at a special base called E, and then we'll look at some financial formulas.